Alright, we're looking at the section limits, and we're first starting off with solving limits using a numerical approach. And of course we'll be moving down to evaluating limits analytically, and we'll kind of talk about that in this on this particular problem here also. So let's pick a problem. Alright, this looks like a good one here. So we're trying to find the limit as x approaches 9 of x squared minus 1 over x minus 1. That's one way to say this, where you could say the limit of x squared minus 1 over x minus 1 as x approaches 9, whichever way you want to do it. I'm going to start off by explaining this problem. Let's first sketch it out on the board and take a look at it from there. Okay, we had the limits. Go ahead and write this in up here. As x approaches, I believe it was 9, of x squared minus 1 over x minus 1. So what I want to do here is I'm just going to graph this function out here, this x squared minus 1 over x minus 1. And the way you can look at the graph is if you factored the numerator, you'd have x minus 1 times x plus 1, and it's over x minus 1. And of course we could cancel terms out in the numerator and the denominator, like terms out, and we get x plus 1. And that's going to be actually what our graph looks like, is this x plus 1 right here. So we got a slope of 1, crosses at 1, and we'll say that's it right there. Of course, this is not going to be to scale. I can see that already. Now we're approaching 9, and I'm going to place 9 out here somewhere. Alright. The actual interesting point on the graph is going to be when x is 1, which is going to be right here, and this is where you're going to really use the limit, this numerical approach, to actually find this y value up here. And the reason for that is because if we were to plug 1 directly in up here, we'd end up with 0 over 0, and that means we've got undefined, it's undefined on the graph. And so where is that hole located? But in this particular problem, we're approaching 9, so you could just do a direct substitution type problem, plugging 9 directly into this and finding out what that actual limit is. But that's not really what the limit definition is. We're going to be actually approaching 9. We're not evaluating 9 exactly at that point, but we're actually approaching it from the right and from the left. And when I say approaching is we're sneaking up on 9. In other words, this would be like 8.5, plug it in, get our value, 8.7, 8.8, 8.9, 8.999, as you could see, and we're sneaking up to, and we're seeing how close we can get to whatever this real value is, and that's coming in on the left. And then coming in on the right, we'll be doing the same thing, like 9.5, 9.3, 9.1, 9. Whatever, as close to 9 as you can get, but not actually use 9 itself. And this thing is called delta x that we'd be using, and like if I said delta x was 0.1, this would be 9.1. We're adding a 0.1 to this, right? And then as delta x gets smaller and smaller, this number gets smaller and smaller, we get closer and closer to 9 from the right and closer to 9 from the left, and compare values. Let me come up here and hit the help button. I've actually got this worked out. So we're approaching 9 from the left, as you can see. So we use 0.1, 0.01. We're getting closer and closer to 9. And of course, we can kind of take a look at what this pattern is actually approaching, and then approach it from the right. Right? And we can make a conclusion that it's approaching 10. So